ask questions, ask any question, use the chat. I'll have that open. Again, the recordings are 100% for you guys. And let's walk through Chapter 2 and Chapter 3 today. Now, with Chapter 2, we're actually going to open up Cisco Packet Tracer and utilize it throughout this chapter. It's going to help us learn how to use what is called here the Cisco iOS. Now, back in the day, Apple filed a lawsuit against Cisco because Apple iOS versus Cisco iOS. Apple wanted iOS. Cisco had it first. It's a long story. You can Google it and find out more. But in the meantime, though, at the Cisco Live conference last week, Apple and Cisco are actually teaming up, and they have a joint logo with both the Apple and Cisco logos on one screen. Very interesting. But Apple, iOS, mobile security, Cisco, enterprise networking and security, very interesting combination to see them joining together. So we'll see what happens for us in the future with Apple and Cisco. Anyways, topics for this chapter then. For Chapter 2, we're going to go through the basics of the Cisco Inter-Networking Operating System, henceforth iOS, Inter-Networking Operating System. Awesome. We'll call it a quick boot camp, but really what it is getting into the iOS and learning how to bounce around and navigate. From there, we'll do a basic configuration of a device, and then we'll finish it off with how to put an IP address on a host, aka a PC. Not too hard, not too difficult. Let me show you the shortcuts. So, jumping into it, our devices are going to have operating systems, and Cisco's, as I mentioned, is the iOS, the Inter-Networking Operating System. The whole idea of an operating system in the first place, you can hop straight into the CompTIA A+ and get this info. Without an operating system, you've got hardware and drivers. We need something to be able to interact with the computer. I need to be able to open up a document to type things or a web browser in order to browse the big, beautiful public internet. Also, I want to send an email. I can't just do it with hardware and do Morse code. Yes, you can. We've done Morse code in the past. Well, that's not what we do anymore. We want an operating system which allows us to have a graphical user interface, something to interface with a machine and be able to send and create messages. So cool. We know that. Let's go further. So an iOS for Cisco is just an operating system, but is an operating system for a Cisco hardware device. This hardware could be a VoIP phone, a voice over IP phone. This hardware could be an access point. This hardware could be a router. It could be a switch. It could be a firewall. It could be an intrusion prevention or detection system. Any physical device that we utilize in Cisco is going to have some type of operating system on it. They're not always GUI. A lot of the stuff that Cisco is putting out as of late, which includes a certain vendor that Cisco bought, known as Meraki, has a beautiful GUI front end. The stuff we utilize in these Cisco courses are called Catalyst devices. We'll be utilizing Catalyst switches and Catalyst, we're not going to go there. Catalyst switches is what we're going to stick with, as well as ASA firewalls, and then Cisco ISR routers. You'll hear these terms more so as we go deeper into our labs and deeper into our courses. What it comes down to is the devices we're going to focus on are going to be command line based, known as CLI. So with an Inter-Networking Operating System, we will be able to have a GUI front end, but most of the devices we utilize in our courses are CLI or command line based network programs. With that being said, we're going to go all out with text-based programming here, utilizing commands to tell our routers and switches what to do. Besides that, our Cisco devices, they're going to have a basic default operating system on them. Just like a computer. You might get a computer, it might come with Windows 7 Home. Well, what if we want more? We'd go for like Premium or Pro. So we'd actually upgrade the operating system. Well, the same thing occurs with our Cisco devices. With our Cisco devices, it's going to come with a default Inter-Networking Operating System, and we can purchase and upgrade our operating system to a newer, latest, and greatest one. We're able to do that. Now, upgrading operating systems is something we do later on near the end of this class, Chapter 11, and we cover it again around Cisco 4. So, we have an operating system, but what is it made up of? Well, an operating system itself is actually going to have hardware that's running on. The hardware is those physical components which allow you to even have an operating system. On top of that hardware, we're going to see what's called the kernel. And the kernel is actually going to allow the communication between hardware and software. Think of BIOS, think of drivers. With that as well, we're going to have the shell, and the shell is where you actually have a command line interface known as a CLI, or a GUI, graphical user interface, where you can actually interact with the hardware below. It's just like a computer, just like CompTIA A+, we have these 3 different levels which allow us to actually utilize a device. So how do we get on a box? Well, when we use the NetLab environment, this kind of goes away because the NetLab environment doesn't require us to open up something like Hyperterminal or PuTTY or TerraTerm, which are terminal emulation programs, in order to access a device. In order to access a device, we have three common access methods. Number one is console, and we'll take a look at this in a couple slides. We'll bring up a picture, and console is utilizing a RS-232 port. What is that? An RS-232 port looks kind of like a VGA port, but the male side of it, and that's a port on the back of your computer known as a serial port. It's RS-232. You plug a console cable into this port on your computer, and the other end of this cable plugs into your networking device. That's a console access. This console access is also called OOB. Too much information here, but you should know it for real world and business. OOB is out of band. And what that means is I have a dedicated cable connected from the back of my computer that plugs directly into the console port on a Cisco box. The reason for that one cable is one reason only: to be a direct connection to configure the networking box. I'm not on a computer network. I'm not utilizing the internet connection to configure my router. It's a console connection. It is out of band. OOB. And out of band means this cable, this connection is off of the network. It's a directly connected cable from point A to point B. No one's going to hack into that cable. No one's going to send their traffic on it. Console connection, out of band. Cool. aux. aux is a special port that we see on Cisco routers. Our Cisco switches commonly do not have an aux port. An aux port is utilized very commonly as a backup mechanism to get into your box. An auxiliary port known as an aux port is commonly hooked to a modem. So if, for example, your internet connection goes down and you can't remote into your site to see what's happening, if you're not physically on site, you can't use the console port, what are we going to do? Well, you can hook a dial-up modem into an aux port on a Cisco router, and you can dial in using a dial-up modem. You can dial in to the aux port on your Cisco router, so you can still connect to it in times of trouble. But the aux port, again, not commonly found on switches, usually only on routers. Next, we have the virtual terminal access methods. This is extremely popular and common. The default mechanism of configuring a Cisco box, the default method is console. By default, a Cisco box that's brand new, router, switch, firewall, whatever, by default, a brand new Cisco box is only configurable on console. When we're on the console, we can then configure the switch or the router or the firewall. We can configure it to be accessible on the virtual terminal lines. What is that? Virtual terminal lines are remote access methods. Telnet uses port 23. It's not encrypted, it's unsecure. We can enable our box to be reachable via Telnet, where I can sit at my office chair with my mini fridge and my tiki lamp and my fan. I can sit in my chair and I can remotely access any of my Cisco boxes via Telnet. The problem is I have to set up Telnet on the box. It is not on by default. And the second problem is Telnet is in plain text. People can see usernames and passwords and full configs crossing the network. Not cool. So what we then want to do is, instead of Telnet, we can activate SSH. On the console, we can enable SSH. So now I can be sitting in my office, as mentioned, and while sitting in my office, I can SSH, which is known as secure shell, to my Cisco box. And when I SSH to a target, it will be encrypted. It uses port 22, and people will see traffic moving, but the traffic will be garbled. They can't understand it because the traffic is encrypted. So these are the three access methods. Just know that no matter what, we always start with console. Console is seen as out of band, is not on the network. People are not jumping on seeing your connection. We then have Telnet and SSH, which are utilizing what is called virtual terminal. We'll get more into that later. Those are remote access methods. Telnet, again, being plain text, insecure, easy to set up. SSH, more complicated to set up, but utilizes encryption. Everything, though, starts with Telnet. So if we were using PuTTY, which is completely free and fun, PuTTY allows you to choose if you want to use Telnet or SSH or serial. Telnet, SSH we've talked about. Serial is just console. From there, we would just type in the IP address of our target if we're using Telnet or SSH. Otherwise, we would just click serial and be able to pick which adapter we're using on our computer. Again, RS-232 port, that's your serial port on your machine. Besides PuTTY, I personally love TerraTerm. This is what I utilize when I do my small business work. This is what I utilize when I work with Cisco, as well as when I teach. I commonly use TerraTerm. It's another free application. It supports, just like we saw previously in PuTTY, Telnet, SSH. It's just the serial adapter is much easier to select here. When you click serial, it gives you a drop-down menu of all the different serial ports on your machine, including USB to serial adapters. I don't have a serial port on my machine or my laptop or my Surface, so I have an adapter that goes from USB to serial. And when I plug in that adapter, it shows up beautifully here in this drop-down menu. So I love TerraTerm. But let's continue. There's another one which people use a lot in CERT training videos, Secure CRT. I've not been too fond of this one. They've been bouncing back and forth between a free model and a paid model of this, so it's up to you if you wanted to give it a try. But Secure CRT is supposed to be a good one though. So we've mentioned accessing the box. And because we've mentioned accessing the box, let's go further. So how do we actually do this thing? Well, we mentioned the console port. Console is always the first method you must use to configure a device. It's console. And we'll see that here, which in blue, it's always this light baby blue, it says console. Besides this console port here, which utilizes an RJ45 connector, our newer Cisco routers include a USB. And this USB, which is that USB-B one, that allows us to also use a dedicated USB cable to console in. Now the common question is, can I be consoled in twice? No, you can't. When the USB console cable is plugged in, the USB port is utilized first before the RJ45 connector here in blue. So let's go further on. We're going to utilize the command line interface of our Cisco routers by using the console port first, either through our serial connector on our machine connected to the RJ45 here, or USB on a machine connected to the USB-B type here, which is the same as the older Android. Also some external hard drives. That exact same port and cable. Alright. So let's actually do it. Let's take a look at some configuration. So at this point in time, what we'd want to be able to do is open up Cisco Packet Tracer. And again, the download link is in the course. Also, you can open up in your local machine, or you could just watch me play here for a little bit. And we're going to walk through some configuration modes and see how this thing works. So I've got my Packet Tracer up and running. I'll drag and drop it over. Here we are. And let's play. So let's purchase a device. Let's go with a 2911 router because they're beautiful, and these are the ones we have on our MyVLab 2 rack, is our 2911 routers. So I'll click on the 2911 router, click on my screen. I have just purchased one. Hooray. From there, I'm going to click on the switches category, and I'm going to take a 2960 switch, which we have these on our MyVLab 2 racks as well. So I'll take a 2960 and click it out there. I'll get a PC for us as well, so I'll grab one end device, grab the desktop PC, and put it up there. Now I'm going to cheat, and I'm going to use the auto cable feature. So I'll just click on the connections, which is that orange Zorro. I'll cheat. I'm going to hold down the control key. By holding the control key, when I click on a cable, now I have unlimited cable. I can just click the router, click the switch, click the switch, click the PC. Cool. I can unclick the cable button, and I'm done. So I have a router, hooked to a switch, hooked to a PC. I'd like to see port labels though. They're not here right now. So I'm going to go to Options, and then I'm going to go to Preferences. In Options, Preferences, I have tons of options here. Let me rescale this thing a little bit. There we go. And I want to say Always Show Port Labels in Logical Workspace. I'll click that. There's no Apply button, which is kind of weird. Just close the window. And now that I clicked Always Show Port Labels in Logical Workspace, check it out. That's awesome. They're there. So I'm going to go in and do some configuring now. Hooray. To do it, it's very, very quick and easy. I'm just going to click on the router. Like, no, that's cheating. You're right, that is cheating. So instead, let's hook up a console cable. Let's do it right. Inside of my cable connections area, you'll see this little blue cable. And when I hover over it, the text at the bottom of the screen says console. So I'll click on my console cable, click on the PC, RS-232 port, which is serial, and I can click on the router. and I want the console port on the router. That's the first initial way to configure the router. Awesome. Now I have an out-of-band connection, which is a console cable directly connected from the PC to the router. I can click on the PC, go to the desktop tab, and on the desktop tab, I want my terminal emulator, known as terminal. I can click on terminal. These are the default settings a Cisco router is using on the console port. 9600 BPS, known as bits per second. Different vendors of networking products will have different speeds on the console port. This is not changing how fast you configure the console. This is just about how the device understands the characters you're sending to it. Just remember it's 9600 BPS. We'll click OK. And now I am live on the box. The first question is, do you want to use the config dialog? That's a step-by-step walkthrough of yes and no questions. That's not what we do. So we say no because we're going to configure this thing from scratch on our own without the router saying, do you want this next? Do you want this? How about this? This is going to be great. You want this? We don't want that. So we're going to type no and hit enter. And now I'm on the router itself. Now you could stay in this terminal area and type and configure, but I want larger text size. So personally, I'm going to bounce out so I can have a better video recording for you guys. So I'm just going to take a look at my font size, do a little bit of bouncing around here, and get something better for our video. And I'm going to click on the router. There we go. So much better for a video recording. Cool. All right. So I'm on the router right now. And again, you can see here it says router. The mode we're in by default. The mode we're in by default has a greater sign. And that's actually called user exec mode. Some people call it user mode. With user mode, also known as user exec mode, this gives us basic commands to type here. How do we know what the commands are? This is Cisco 1. Hit the question mark. When you do shift and the key to make a question mark, you can see all the possible options here in this user exec mode that we can do, along with the description of what they are. We can use a connect command to disable, disconnect, enable, log out, ping. You get it, there's a lot here. Now with Cisco and the iOS, the first thing you have to get rid of in your mental thoughts are, this is a lot of stuff. I'm not going to remember every single command. Am I memorizing this? No, not at all. You memorize the commands you need to use for a specific course. In the real world, you memorize the commands you need to use for a specific network environment. There is no one person in the world that memorized every Cisco command. It's not happening. I hate to burst your bubble as well if you want to be that person, but there actually are hidden Cisco commands that are not shown when you use the question mark. Commands that exist, but they're not documented and they're not shown. I found one of them when I was doing my CCNP studies. Hilarious. That's just say you can tell a router to pretty much kill itself. Yeah. You want to experience a network failure in real time? You can actually make your router network fail on its own. Literally. A command to have it literally shut itself down and try to fry itself. It exists. How do you know your network's going to respond if there's a crash of some sort? We can tell our router to actually crash. So, cool stuff. But let's continue. So here we are. We use the question mark command, and this showed us all of our options here in what is known as user mode. And user mode, again, is the greater sign. Hooray. Let's continue. To have a larger amount of commands we can run, to be privileged and be able to have more power, there's a command called enable. When you type in enable and hit enter, your prompt's going to change. It's going to go to a pound sign. And the pound sign is the next level in terms of you being able to enter commands. This is called privileged exec mode. Some people say executive, but it's really privileged exec. That's what this mode is with the pound sign. And with privileged exec mode, you can hit question mark here and take a look at that. A lot more options than before. Now we have auto, clear, clock, configure, connect, copy. You can read them all. Make directory, MKDAR, just like, yeah. You're like, I saw that before. No, ping, reload, more. With more, you can either hit the enter key and it takes you down line by line, or you can hit space bar and it'll take you down by section. You get to pick. Not a big deal. Either way though, because we used the enable command, which took us from user mode to privilege exec mode, we now have a lot more power. There's a lot more stuff we can do here, including dangerous things like delete and erase. We didn't have that ability before. All right, so we've gone through that. That's awesome. Now it's time for us to continue even further. So if we wanted to configure something that's like turn on a port or turn off a port, or let's change our name, let's make a banner message for the entire world to see that says, hey, welcome to switch 1 or something. Let's do something like that. Well, that's where we start working our way into it. We need to start navigating, bouncing around deeper into the Cisco IOS in order to make changes. So back to my packet tracer environment, let's go deeper. To go deeper, there's a really long-winded command known as configure terminal. Like, what is that? Configure terminal allows us to go into what is known as global configuration mode. And configure terminal, you can type the whole thing out. Or what you're going to start seeing in Cisco is there's shortcuts. Configure T is a good shortcut for configure terminal. Also, we can shorten configure to just config T, and that's going to work too. Like, well, why is that all working? Because what we're about to see is that when you're typing commands in Cisco, if there's no other command that starts with config ter, then I can just type in configure ter, and that'll do the same thing as terminal. If there's no other command that starts with confi except for configure, I can just type in confi, and it'll do the same command as configure. Does that make sense? It's kind of weird. But you can shorten the command as long as there's not two commands that use that exact same string of characters. That's what I mean by that. So configure terminal, also known as config T, enter. And now I'm in my router config prompt with a pound sign, and this is global configuration mode. And this is where, as we make changes here, it's going to affect the entire box as a whole. Like, for example, I can type in host name, which is one word. I can type R1. And when I hit enter, it changes the name of my box to R1. Cool. Well, let's go deeper. Let's take a look at interfaces, and let's take a look at the console. Okay, interfaces. This is a router. I can say interface I can't spell, gigabit Ethernet 0/1. Like, how did you know you had that port? Because I know this router. But interface gigabit Ethernet 0/1. Watch this. Uh-oh. Error. Like, what do you mean error? Error. Well, there's something wrong here. In order to figure out what's wrong, there's a little marker that's shown. Invalid input detected at marker. What we can then do is try to retype this. I can type it all out again, interface. Well, that would take a long time. There's shortcuts. You can use the up arrow to retype your last command. So, up arrow has history. Then I can pull that back and hit enter. It says, uh-oh, error, we don't like this. You're like, I gotta retype it again? No, we can hit up arrow to retype, and then scroll back and remove the space. Interface gigabit Ethernet 0/1. Now it likes the command. It did not like that I had spaces in between the interface naming convention. So in order to get into gigabit Ethernet 0/1, which is a gigabit port on my router, I had to type in interface followed by the name of the interface 0/1. When I hit enter, it takes me into the interface. I'm no longer in config mode, which is global config. Now I'm in config interface. We've gone even deeper into the Cisco IOS. Well, what can we do here? Hit question mark and find out. When you hit question mark, you'll see tons of options. Everything from the ARP protocol to resolving addressing, to bandwidth commands, to speed and duplex commands, descriptions of what the interface is even for, IPv6 commands, IPv4 commands, PPP, like what you use at a DSL modem at an office, like with like Yahoo, DSL, and other things, AT&T. Enter line by line to get more, or spacebar to go by section. But you'll see tons of options that we can utilize on our port. Again, you're not here to memorize all of these. Even through the CCNP classes, you're not here to memorize all of these. We learn the commands we need for the most common network environments, and you figure out the rest on the go as you need it. Just real life, real world. So when we're here, we could do commands like shutdown, enter. And shutdown, followed by enter, turns a port physically off. Like, boom, done with it. Power switch off. That port is not in use. To turn the port back on, the command would be no shutdown. No shutdown just means remove the shutdown command, which is the same as bring it on. Enter. Hooray. So let's continue onwards. We're kind of done. We've gone as deep as we can. So in order to go back to global config mode, we need to back this truck up. And to back this thing up, the command is going to be exit. When you type exit, watch the prompt. It goes back to global config mode. If I type in exit again, it goes back to privilege exec mode. If I want to go back into global config mode, config T, which is short for configure terminal. Enter. Cool. So lastly we want to play with here is going to be setting up our console line or our telnet or SSH. Now it's not going to be interface console, and when people first play with this they get a little lost. Console and VTY lines, VTY is for telnet and SSH, are all done with a command known as line. So what we actually have to type is kind of weird, but you'll get used to it as you do it more. The command is line followed by console, and with Cisco every number starts with 0. Everything starts at 0. 0 is a valid number. There's only one console port on a Cisco box. You're like, but I thought you had that USB one. I know, but you can only use one at a time. So by default, we still say there's one console port on a Cisco box. So line console, and if you don't know what to type, you can hit question mark, and it says the only thing after line console that you can type is 0 or 0. That's it. It's not making a funny face at you. It is either 0 you can type or 0 you can type. So we'll say line console 0, and we'll hit enter. And when we hit enter, we're now in the console line where I can use question mark to view my settings. And in the console line, now I can configure how my console port works. I can configure anything such as banners. I can configure timeouts. I can configure passwords and authentication. We can control how our console port actually works. So it's not just, yeah, you plugged a cable in, now you can configure my box and have full access. No, we can put passwords and security on this thing if we wanted to. Sweet. Lastly, I'll type exit to back out. If I wanted to configure the remote access lines, the remote access being telnet and SSH like we talked about, that would be line VTY. And VTY is for virtual telephony, and these lines here are kind of weird, but these lines exist on the motherboard of your box itself. On the motherboard. They're not using physical ports. These are actually reachable on the motherboard of your router, switch, firewall, access point, you name it. But what do they look like? What are their numbers? How many? Well, after you do line VTY, space, question mark. This router has 16 remote access lines. I can have 16 people telnetted or SSH into this box at one time. 16 people can be working on it at any given moment. So to identify 0 through 15, which makes 16 numbers, I would say 0 space 15. Line VTY 0 space 15 means hit all 16 lines. When I hit enter, again I see config line just like with the console, but this time it's not console. This time it's my 16 remote access lines because that's what I specified. Again, I can use question mark and we can see the options here, a little less than the console port. Again, I can put anything on here such as banner messages to say, hey, you've arrived at the router, welcome, make sure you authenticate. I can put passwords on there, time limits, and timeouts, and we'll get more into that as you go deeper into chapter 9, 10, and 11. So we've used the exit command, which takes us back one step. There's another command, though, known as end. And end will bounce us all the way back to the beginning. I'll type end and hit enter, and it takes me all the way back to privilege exec mode. So it goes back to config T and back to privilege exec mode with one command, which is the end command. You can also use Control C and Control Z. Both Control C and Control Z also perform the end. Alright, let's continue. So we played with it, we bounced through these different modes so far. Let's keep moving. We've identified the user exec mode, privilege exec mode, we've worked our way through that. Basic config, we've bounced around in the interfaces, we've also bounced around in the console and VTY line. We're good to go from here. Let's actually hop in and do some live real configuration for this packet tracer network. Before we hop in and do this actual configuration, let's take a 5-minute break to make sure everyone is still with us and all the light bulbs have not exploded and they're like, I'm done. Let's take 5 and we'll continue on. So we're going to go through device name configuration and then also basic security. So back to the Cisco packet tracer and back to my router. Let's actually get these devices up and running. Now I've already showed off the hostname command, and that was just inside of my global config section, which is configure terminal, shortened also to config T. And inside of there it's one word, hostname. And with this command hostname, host names need to start with a letter. You can't start with a number or with a special character. It needs to start with a letter, like the word router. Now, they cannot contain spaces. You can't do router space floor 1. You can't do that. If you want to have anything that looks like a space, you can use some special digits or dashes like an underscore or a hyphen, and then there you can say like -1. These host names have to be less than 64 characters in length. Commonly, just make them mean something and make them unique. Don't just have every host name be router or switch. These host names are not just used as a label in command line. These host names are also utilized by network tools that you run on a computer or on a server that actually can see a device and will report its name. So these names, you want them to be unique across your network environment. So for example, router-1, enter. And when you use that command, again, the name of the router changes live right there on the spot. So going further now, we actually want to lock down our box. So I'm going to type end, and end will take me all the way back to my privileged exec mode. Exit, remember, goes back one level. End takes you all the way back to the #, which is privileged exec, from wherever you are. Now, this # here, privileged exec mode, we got into this mode. We weren't here by default. By default, we were in user exec mode. Let's take a look at that again. To get out of this mode and go back to user exec mode, I have to type the command disable. Disable is the opposite of enable. We had to type enable to go from the greater sign, which was user exec mode, to privileged exec mode, which is the #. So when I type disable and hit enter, it takes me out to user exec mode. Now commonly people say, well, what's the purpose of this # mode? Why do we have this extra step of greater sign user exec mode, # privileged exec mode? Well, the reason we have this extra step is it gives us a place to lock down our box. Here in user exec mode, if I hit question mark, we have very basic commands. We don't have a delete command, we don't have an erase command, also we don't even have a configure command. It's very basic here. This user exec mode is the first stop when someone is on your box. Think of giving an intern access to your network box, whether it be a firewall, a router, a switch, an access point, whatever it may be. But if you were to give an intern access, do you want them to be able to erase your entire box? No. So we can give them user access, which is this which is greater sign mode. If we wanted to prevent them from going further, we can lock down this mode. Let me show you how. First, we need to get into our configuration mode. Enable, which takes us to the privileged exec mode. From privileged exec mode, config T, which is the same as configure terminal. And now we have a password that we can lock down that user mode with. And it's called enable secret. Enable secret is the commands. The actual modifier, the actual word we're going to use as the password, follows next. And I can make that Cisco. I can make it class. I can make it student. Whatever I want to do, I can make it. I can make it something horrible that's like 35 characters long. To make it easy, the enable secret I'll make is class. And this says when people try to go from that user mode to the privileged exec mode, they're going to need the password of class. Now besides enable secret, there's another command you can use here known as enable password. Enable password is old, it's legacy. Enable password, followed by class, would do the exact same thing as secret. It would require the use of class as a password for people to go from the user mode to privileged exec. The difference though is enable password does not use encryption. Enable secret actually utilizes encryption and hashing, and enable secret will use an MD5 hash by default. Enable password, plain text. Now you can activate both enable password and enable secret. You can turn on both. But just know, once enable secret is turned on, it will always supersede and be used in replacement of enable password. So if I said enable secret class, and I said enable password Cisco, and then I type exit, goes back one level, disable, takes me out of privileged exec mode. Now I'm in user mode, and I set an enable secret of class and an enable password of Cisco. When I type enable to get into my privileged exec mode, it says you need a password first. Check this out. I'll try Cisco, which is the enable password, CISCO. It doesn't show me typing, but I am typing. This is for shoulder surfing. I did type the word Cisco just now. You can't see it though. When I hit enter, it failed. I'll try it again, CISCO, Cisco. It's right there. I'll hit enter again. It failed. What the problem is my router understands I've configured an enable secret and an enable password. The router is waiting for the enable secret to be used. Once I type in class, CLASS, enter, took it immediately. Always know that when you have an enable secret and an enable password, the enable secret is what is utilized by your box. The enable password is ignored. If I removed the enable secret, then it would take Cisco as the password to go from user mode to exec mode. Now, this is an awesome way to lock down basic access to your box. Let's continue. Did it? To lock down the console port itself, that port that you have plugged in your console cable into, the first way you access the box, we got to actually lock down the console line. Now with this, it's very important because by default, anybody can just plug a cable into your box if they have physical access to it and they're on it. Well, we got to stop that from happening. So back to my packet tracer, back to the router. To lock down the console, config T, because you want to configure something. Line console 0, because remember, there's only one console line, and Cisco always starts with the number 0. Line console 0, enter. And now inside of here, we're going to use the command password followed by what password we want this to be. How about Cisco? Password Cisco. But now we actually have to tell the router to password check. Hey router, use password checking. Well, there's a command for that. The command is login. And login actually means I want people to be asked for a password here. Without this command, people are not asked for a password. For example, people will try to confuse you. If you use the command no login, you're like, awesome security, you've locked down the console port. No one can log in. It's actually the opposite. No login means no password checking. So I'll make sure that we actually utilize the login command. And the login command says, hey, check for passwords. And by the way, the password is Cisco. So besides the console port, which is our hardwired console cable from our PC's RS-232 port to the console port on our Cisco box, we'll type exit, and we have our remote access lines to lock down. That's line VTY, like we saw before. 0, what's the last number? Space question mark. There it is. We can either go 0 to 1 or 0 all the way up until 15. Let's get them all 16 lines. 0 space 15. Enter. And again, password Cisco, login. Says the password of Cisco is what we'll use to authenticate, and we are checking passwords, henceforth the login command. So this is awesome. How do we see what we've done so far? Because we've kind of, we've done host names, we've done passwords. Well, let's see what we've done. You can either type end, and it'll take you all the way back, or you can hit Control C. And Control C or Control Z, either way, takes you all the way back to privileged exec mode. What we want to use is the command show run. Show run is actually short for show running-config. And running-config is your entire config that you're working on right now. Right now it's stored in RAM. RAM is erased when you reboot a router. So right now your configuration is running on the box. All the changes you're making are running on the box right now. And to see those, it's called the running config. So we do show running config and hit enter. And now we get to see, our running config. All the commands. We have a host name of router -1. We have an enable password here in plain text of Cisco. We have the enable secret, which was class. Look at that garbled mess. This is the equivalent of class in garbled mess, known as the enable secret command. There's something called service password encryption. It is off by default. We see there's a no in front. This we're about to activate. Service password encryption is a service. It's something that runs 24/7 on your box when you turn it on. Like a Windows service. When your box is on, you have services running in the background. And the service is very straightforward. It's called password encryption. Oh, I wonder what it does. I think we know. So anything that's plain text in our config can be encrypted by us activating the service, which we'll do in just a couple minutes. If I hit the enter key, it goes down line by line, or a space bar will take me by sections. I can take a look at my interfaces, see the commands on them. Gig 00 is in shutdown, it's physically off. Gig 01 is on because Justin used the no shutdown command earlier with you guys. Gig 02, it's all default, still turned off, we haven't touched it. Again, spacebar, I can bounce further down. Line console 0, my console line has a password of Cisco, it is checking for passwords. My VTY lines separated in a set of 5 and a set of 10 here, 0 through 4, 5 lines, 5 through 15, 10 lines. They both have a password of Cisco, and they're both actually checking authentication. Now the bad thing in this config is anybody shoulder surfing can read all my passwords. Not cool. So what I can do then is hit spacebar, get back to my privileged exec prompt, go to my config T, which is my configure terminal, and we're going to turn on that password encryption service. To do it, it's just service password hyphen encryption. And you'll memorize this over time as you do it more. Right now it should just be written in your notebook of tools. But service space password hyphen encryption, enter. No fireworks, no hooray you did it, now your passwords are encrypted. Now it's just going to take any plain text passwords, and before it shows you in a show run, it's going to encrypt them. Let's see. I'll hit Control C or Control Z, whatever. And then I'm going to do the show running hyphen config command again, which will show me my config. But this time, all those plain text passwords are going to be in a type 7 encryption. Type 7 encryption. Yeah, type 7 is just the type that Cisco created called type 7. And now the word of class now shows as this, 082245, blah, 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 blah. And if I scroll down to my console and VTY lines, my console and VTY password is Cisco, 08224555D, whatever, whatever. So we have this basic encryption. And I'm saying basic because this is not meant to be like NSA, stop the world from hacking everything. That's not what this is for. And let me show you why it's not for that. Because if I were to open a web browser and go to Cisco Password Cracker, there we go, Cisco Password Cracker. Sure. Oh, here we go. Check that out. Type 7 password. Yeah, what was ours again? Type 7 password. Copy. Paste. Crack. There you go. See? With this coming into play, a type 7 password is for screen watchers. That's a nice way to put it. People who stand behind you and read your screen when they shouldn't be. Or maybe you're asking for help on something and they want to look at your config to help you. This is just hard for them to memorize when they're standing behind you. That's what this type 7 password is for. If you want to use better encryption like script, SCRYPT, or SHA, you can. But that's not for our course. That's for CCNA security. Different class, different certification. So there's other ways to do it. But for now, we're teaching the basics. And the basics is, for shoulder surfing, John's going to have a hard time remembering 0822455D0A16 as they're helping you with your config or standing behind you. Let's continue. Cool? Cool? Banner messages. Legality. There was actually an issue. There was a time where there was a bunch of students on a computer network who were having fun. And these students were sniffing the network and utilizing a tool that was surveying the network and finding ports that were open. When you find ports that are open like port 80 and port 23, you're like, hey, those are management ports, using a web browser on 80 or using Telnet at 23. So they decided to go further and they started pecking their doorways and finding that there's no authentication. This is cool, look, I can play on this. And then they took down a college network. The college network went down for the period of 8 to 12 hours. College tried to sue the students. Students, we didn't know it was a live production device. We thought it was something to play with. Students got off scot-free. So in order to make sure that for legality purposes, number one, people know they're on a device they shouldn't be accessing, and also number two, so a company can prosecute someone when they mess with a device they shouldn't, we need legal messages, and that's what this is about. We need a banner message. We got to let people know that they're not welcome. That's about it. You got to be mean. You're not welcome here. Go away. So to do that, right now our device is fair game. There's no message that says you do not belong here. So let's create one. Config space T, short for configure terminal. And then we're going to create what's called a message of the day banner. The command is banner space MOTD, which stands for message of the day, MOTD, space The craziest thing in the world. If I hit question mark, Cisco will speak to me in gibberish. Line C, banner text C, where C is a delimiting character. What that means is, after banner MOTD, you're going to type in a weird, crazy character, like a pound sign. And then you type your message, like authorized access only. Do not trespass. Please ask for permission to use our property. There we go. Exclamation point. And whatever that first character was, known as a delimiting character, what this whole crazy thing means, line C, banner text C, just means type that delimiting character again at the end. That's all. And make sure that character you use is not in your text. Because if that character you use to start your message exists in the text, it's going to cut your message wherever it finds the character again. A router doesn't speak English. That's all I got to say. So we have to tell the router when we're starting the message and when we're ending the message. That's all. Enter. Cool. Well, how do I know if it worked? Oh, we're going to find out. I'll hit Control C, and then I'm going to type in one crazy awesome command known as log out. Log out is one word. I'll type log out and hit enter. I've literally been logged off the console port. Once I hit enter, it'll log back on the console port and check it out. Once I hit enter, it says authorized access only, do not trespass, please ask for permission to use our property. Woohoo! Now I could have this whole like 5-paragraph thing here. I could have put an ASCII art of skull and crossbones, maybe the Jolly Roger. You could do that. But at least we have some type of a legal message saying it's not a toy. Don't play. It's not a fun simulation environment. This is legit. So, password, what is that? Well, we're on the console port. We are physically plugged into the console port on this router. The first thing we're being asked for is not an enable secret. This is the console password, and that was going to be Cisco. Enter. And now I'm in user exec mode. I type enable to go deeper. Give me more power. Enter. The enable password was class. Class because it was enable secret. Enter. So I have all this methods of authentication and legality here now. I have a banner message when we hop on the box. I have the console password saying, hey, should you even be accessing the user mode? What's the password to gain access? And then when you get into the user mode, hey, should I be having access to much further advanced configurations that are more powerful? Use the password of class. And you work your way through the system now where now I can finally configure something. But this is awesome because we're putting levels of security for our Cisco Internet Networking operating system. And the neat thing is we're on a router. This command structure works the same on a switch as it does on an access point, as it does on a Cisco firewall. The Cisco iOS Internet Networking operating system is pretty legit across all Cisco platforms. So you learn how to configure a router, you've already learned how to configure a switch then. The Cisco ASA firewalls are a little bit tricky sometimes with the command structure, but our switches and routers and access points are very common in how those command structures work. So we've disinvited people, and we've utilized passwords. So let's continue. As I mentioned, we used the show run command, and the show run command gave us the live config on our box. But what happens if our box loses power? Well, everything we're doing right now is in RAM. Like, why would we want it to be in RAM? Well, by default, as you configure your box, all the configs are being put into RAM. The router is running the configuration file out of RAM 24/7, out of the RAM itself, just like the RAM on your PC. So if I were to reboot your PC or reboot the router, everything you're doing right now that's stored in RAM is lost. Well, why is that a good thing? Imagine if you're configuring your router, going to town, and you're like, this is awesome. Then you create something like this, enable secret, blah, and hit enter. Well, what happens if I get locked out of my box? Well, you lose everything, right? You have to start from scratch. Yeah. Or, what happens if I saved my work when everything was beautiful? Well, when you save your work in Cisco, let me show you how to do it. Control C. In privileged exec mode, to save our work, the command is copy, followed by where it's being saved from, and then going to. Copy, and then the from is going to be running -config, which is RAM. Copy from what's in RAM right now. And I don't want to lose what's in RAM, so I'm going to save it somewhere special known as startup-config. Startup-config is in a special place known as NVRAM. N as in Nancy, V as in Victor. NVRAM. NV stands for non-volatile. Non-volatile means when you lose power, your config is still there. Normal RAM is volatile. Normal RAM is wiped when you lose power. NV, non-volatile RAM, does not lose its contents when you turn off the power. So what we're saying here is copy what's in my running config, which is my scary volatile area, which is the router's running it right now, and put it in my startup config, which is my not volatile RAM. When I hit enter, it says, do you want to name the file startup-config? Enter. Yes, I do. Do not type Y. Because if you type Y, you're going to save your file as the word Y. What we see in brackets is the default that's going to occur when I hit enter. When I hit enter, it'll by default name it startup-config. Hooray. So now all my work right now is now stored in my NVRAM, non-volatile RAM, which is my startup config. And the reason this is so important is because when your router boots for the day, when it turns on, it's going to load the configuration out of startup config. That configuration is loaded where? Where is it put? It's loaded from startup config and put in your RAM. When your router boots, your router works out of the RAM. So it boots up any file stored in startup config and then puts it in RAM where you can edit it and work on it. When you're done working on it, you use your copy run config startup config command to save it for tomorrow. So yay, we've copied our work, it's all on the startup config, we're good to go. Then we blow it up by doing enable secret blah. And now, if I were to go all the way out and disable, try my enable command, I don't know how to repeat the blah. I've lost all my work, I'm locked out. Well, I didn't lose it all. My great config was saved in the startup config, which is where my router boots from. I never saved it after creating that horrible enable secret. So all I have to do is literally physical power off that box. And there's a power button. Power the box back on. And then when the box finishes booting, guess what? It was last saved before I did the horrible, annoying, crazy enable secret command. And this is simulated in Packet Tracer. I can click fast forward. Woohoo! Jump by 30 seconds. Who needs to wait for a router to boot? This is real life. So after doing fast forward, look, the router booted. And enter. Console password, Cisco. Enable. The enable password was class. Hooray! But I thought the enable password was the gobbledygook message. It was, but I never saved it after making that horrible thing. It was last saved when I had a good configuration. So that's the example of why we are working out of RAM. We're working out of RAM because if something blows up on our face, we can just reboot the box and it boots from our last known saved config. Cool, right? And that's why we work out of RAM. Hooray. So let's finish our lecture now. That was cool. So addressing, very, very basic, nothing too crazy. We're going to work with IP addresses. We have IPv4 and IPv6 in this class. We'll get more into that as we go towards chapter 6 and above. But with IP addresses, this is the basis of how the internet works. We're going to have decimal numbers that go from 0 to 255. There's no 256 in IPv4. In IPv4 addressing, you'll have 0 up until 255. IPv6 addressing is the most recent version of IP, and we will learn it. You will get there, and I will test you on it as we burn through this class and the remaining 3 Cisco courses after this, but we'll really make IPv6 awesome. With our interfaces and ports, these are commonly interchangeable words. With interfaces and ports, we're really focusing on network-connected interfaces and ports that allow us to connect to networks themselves. Don't worry about that too hard. It's really just the same interused term. So what we need to be able to do is put an IP address on a PC. And it really is pretty easy. Depending on your operating system, the goal is to get to your network adapters. And to get to your network adapters, there's actually a couple ways to do it. In the bottom right corner of your computer, you'll actually be able to see your clock icon, and next to that is usually going to be a networking icon. So for me right now, it's not over there because my screen is set up a different way, but I can fix that. Why not? There we go. That's better. Hooray. Thank you. So we have our networking icon on the bottom right corner. I can right click on that and go to Network and Sharing Center. With Network and Sharing Center, I can go on the left side and click on Change Adapter Settings. And in here, I see my NIC card. I can right click on my NIC card, known as my network interface card, and click on properties. Instead of properties, I'll be able to see here IPv6 settings and IPv4 settings. For now, we're sticking with IPv4. So I'll click on it, and I'll click on properties. At this point in time, I can utilize DHCP. DHCP is how we dynamically receive an address and a subnet mask and a default gateway from an upstream router that's running DHCP, or from a dedicated DHCP server. If I didn't want to use DHCP, I could click use the following IP, and I can statically type in an IP address here, like IAM10001, tab. My subnet mask is 255 all zeros. My default gateway, my exit of my network is 254. Now if that's legit and that's correct, you could do it. We commonly do static IPs for servers, we do static IPs for routers, we do static IPs for access points, for network printers. Anything that you really are afraid of, if it changed, you're going to lose some type of connectivity, you use a static IP for it. Because a static IP will be a permanently assigned address. But anyways, DNS, we use that for name resolution, such as whoisgoogle.com, Google. Well, your computer has no idea what Google even means. So any request to a named target, your computer will target this address, whatever is in your DNS settings. All 8s is actually Google's DNS server. Cisco purchased OpenDNS, which I want to say is 208.67.220.220. That's Cisco's DNS servers that they own. So you can have these DNS server info that can be learned automatically. You can have IP address info learned automatically or statically typed in. Either way, when you're done, you have to click OK. And by the way, you also have to close your network card properties. If you don't close this next window, whatever settings you change will not actually take. I've had so many students work on a lab environment and they're like, why is it failing? Where's my address? I configured my address. Unless you click close on the properties window, it will not actually make changes. Windows has a little bit of a nuance there. So anyways, let's continue. Hooray. Oops. I gotta put my window back. There we go. Make my main display. Thank you very much. Hooray. And now we can continue. Awesome. So yeah, statically assigning an address manually or dynamically using DHCP. I think we're good. After you have an address, we have some basic command line tools to use. Then we'll call it a day here. To get to a command line, all you gotta do is just click the Windows button on your Windows machine, or you can open up a terminal in Linux. And we have CMD, cat, mouse, dog, if you're using Windows. And CMD, cat, mouse, dog, will give you your terminal. And here, my terminal. And I can use commands like ipconfig. With ipconfig, it says you are in the marinevalley.edu DNS, which is the domain. Hey, look, check this out. Your IP address is 192.168.1.28. Your default gateway or your exit point is that. If I want more info, I can type ipconfig space /all. And with space /all, huge amount of info here. Not only do I get to see my host name of my machine, desktop, blah, 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 my IPv6 address, yes, I have one, kind of cool. I also get to see my MAC address, 90E6BAA836F2. That's the physically burned in address on my NIC card, known as my hardware address, Ethernet address, layer 2 address, MAC address, BIA address, tons of different names for a MAC address, but it's right there. I can see DHCP is enabled. Not only can I see that, check it out, DHCP server. Who is my DHCP server? It's my router. Kind of cool. You can see that there too. DNS servers, these are the college's DNS servers that I'm utilizing as well. Sweet, huh? Anyways, close it down. If we wanted to be able to put an IP address, not just on a PC, but how about on a router or on a switch? It's actually really easy to do. So let's go do it on a switch. Back to packet tracer. Click on the switch. If I want to configure an IP address on a switch, well, why would you do that as a switch? Well, what if you wanted to remotely configure, remotely access the switch? I'd click on CLI. And here we are from the beginning. You can do this on your own now. We're in user mode, so we want to go deeper. Enable. We're in privileged exec mode. We want to configure something. Config T, which is short for configure terminal. Enter. Now I want to actually put an IP address on this switch. Say interface VLAN 1. You're like, VLAN 1? This guy's crazy. What's VLAN 1? VLANs are a very interesting and awesome topic. We get to VLANs in Cisco too. I am so sorry I have to use this command here, but in the Cisco material, they want you to use it. In this context, interface VLAN 1, it's a logical port. It exists virtually on the motherboard of a switch. Motherboard of a switch. There's a port virtually there. There's no physical cable to plug in, just on the motherboard of the switch. Just keep that in mind. Int VLAN 1, enter. I'm in interface mode now. And in this interface mode, I'm going to give the switch an IP address. So I can remotely hit this target and configure the switch via whatever this random interface VLAN 1 is on the motherboard. So I would say IP address 192.168.1.2 because I can. Followed by a subnet mask. And we'll go through subnet masks in a later chapter if you've never dealt with them before. The subnet mask just defines how big a network is. Cool. One long line. IP address followed by the subnet mask numbers and then enter. One long configuration statement. To actually bring this virtual port up though, this VLAN 1, we have to use the command no shutdown. Just like on the physical ports on the router, no shutdown turns the port on. So we see here the port has changed the state to up. Hooray. Now, we gave the switch an IP address, but in order for this thing to be reached by anything, we kind of have to go on a PC in Packet Tracer and give an IP address too. Very easy to do though. PC, click on it. Desktop tab, IP configuration, and we'll statically assign an address on the PC, 192.168.1.1. The switch is 1.2. That's cool. Subnet mask, I just hit tab, fills it in. Default gateway, DNS server, we don't need that info. We're not going anywhere outside of our network. We're not leaving the door. That's only needed for a default gateway if we need to leave our network, which we're not. I just want to have an address and a mask, just like the switch. I can close that window. Open a command prompt, just like CMD on a Windows computer or terminal on a Linux command prompt. And I can do this. I can say ping, which is a go out and hit something command. 192.168.1.2. That's the address of my switch. Can I hit my switch? Hit enter. It'll send 4 responses. Go ahead. Go hit that switch. Failed. Success, success, success. The first one failed because the PC did not know who the switch was. And that's something we'll talk about more in Chapter 3 and Chapter 5, which goes into ARP. Who is 192.168.1.2? Let me know who you are. What's your MAC address? I can't target you. I can't build a message unless I know who you are. So the first message failed. Afterwards, the next 3 were successes. So I was able to reach successfully the 1.2 address, which is the switch. Cool. It exists. So let's close it down. If you want to verify that switch and actually see that interface up and running, besides just doing the ping from the PC standpoint, we can actually go on that switch, and on that switch there's a couple show commands we can use. My personal favorite is show IP interface brief. Show IP interface brief. It'll list every single port on our switch and give us information on it. Let's see it. Once I hit enter from the top, we have fast Ethernet port 0/1. It has no address assigned to it. It is in a down state. Fast Ethernet 02, no address is assigned, but we are up and up. This is the port that plugs into the PC. Spacebar. We have VLAN 1 with an IP address of 192.168.1.2. This is in a state of up. Why are there 2? There's commonly 2 because status is about the physical, on or off, and protocol is do we actually have a connection on that port. Physically on/off, does a connection exist? We'll go more into that as we go deeper towards Chapter 11. So that's going to be it. This is where we close it down. We've already done our ping. We made sure the PC can actually reach that switch. There is reachability, and that's where we end Chapter 2. So in the meantime, make sure you hop on and get started with the labs. Also, if you want some more reading, which I highly recommend, Amazon, woohoo, or Moraine Valley Bookstore, woohoo, but Amazon, yay! We have the Cisco Portable Command Guide, and this is really the way to go. One book, Make sure you get the right version. This version is the 4th edition, like 23 bucks. Literally, 23 bucks. One book. And this book is good for all 4 Cisco classes. LAN 122, which is Cisco 1, 246, which is Cisco 2, 256, Cisco 3, and 266, Cisco 4. This one book covers all the topics for the entire CCNA certification exam, which all our 4 classes line up to. With this book, it walks you through not as a dictionary of here's a command, here's what it does, but this book actually gives you network simulations. What I mean by simulations is in a book form, it gives you a topology showing you a network that's currently built and designed. Then it walks you through the commands you'd utilized to make the technology such as static routing, EIGRP, access control list, SSH, VLANs. It walks you through all the configs of those topologies and when and why you're using those commands. Awesome and amazing book. A lot of people say this is what helped them pass their cert exams. And besides that, this gives you the knowledge of when to use what commands for the Cisco Academy courses too. 23 bucks. 4 courses, you're talking like, what, $6 a class if you're talking about purchasing a book. Buy it, ship it to yourself. eBay, Amazon, wherever you may get it from, it is well worth it. I have 3 copies on my desk. I love this book. I take one with me everywhere I go. I also have a CCNP version. There's a CCNP portable command guide too, and it is just as phenomenal. So get this book. Highly recommend it. It will help you out in your classes. Otherwise, make sure you do the course reading. Rock through this. Work on the labs. Let me know how I can help you, and we'll proceed from there.